Hello my scholars, welcome to my school channel. So in this clip, we'll be solving questions number 21 to number 40. So make sure you follow through each steps as we solve these questions. Join me as we solve question number 21. When the downward current flows in a straight vertical conductor, the direction of its magnetic field at a point due north of the wire is what? So just take note of your Fleming's rule, okay? You have something like this. This makes the force or the motion, the force on the wire carrying the current, okay? This is the magnetic field, okay? And this stands for the direction of the current. So if we are going to make here north, just like the question indicated, just have something like this. Okay, so when the downward current flows in a straight vertical conductor facing north, so this is facing north now, this would definitely be our magnetic field. Okay, so this finger you are seeing here, my index finger, if this is north, that is going to be west. Okay, and therefore the force on it will provide angle 90, right angle, okay, to both the current and the magnetic field. So looking at it, if the magnetic field, if the current rather flowing is facing north, this is what we are going to have. The magnetic field will be facing west. So the correct answer is option D. Question 22. Aluminium is sometimes used as the leaf of an electroscope because it's, option A, is a light material. Not just that, option B is a good conductor. Of course, aluminum is a good conductor of electricity, okay? C is a good insulator. No, that's definitely not. Then let's look at D. Can be converted into thin sheets. Of course, whatever leaf that you'll be using in your electroscope must be very thin, that they don't have any form of rigidity. So, and that is what aluminium and gold can do conveniently. In short, the principle of which electroscope works is that two like-charged leaves are being used. So they are going to work on the principle of like charges repel each other. So once current is being introduced, once they are charged up, okay, they are going to deflect away from each other. So they have to be very light as possible, so thin that they lack no rigidity. That's very important, and they can be easily deflected from one another. So the correct option is option D. Question number 23. The diagram above represents the stress-strain graph of a loaded wire. Okay, so which of these statements is correct? At J, the wire becomes plastic. No. This is point J, okay? J is the yield point. Why? Because at the end of point J, this point we are seeing here becomes the yield point where the material cannot regain its original or initial shape. L is the elastic limit. No, L stands for the breaking point. I is the elastic limit. Okay, at K, the wire breaks. The wire doesn't break here. Although when you increase load, then you begin to move towards your breaking point. So at still K, the wire doesn't break, okay? So the wire begins to break at point L. So option B is correct. At the end of J, we have our yield point. Dear my scholars, it is very necessary that you prepare towards your coming exams. We have provided you with tools that you can use to enhance your confidence and competence in writing those exams. So we have the Myschool mobile app or the Myschool software. You can get any of these our tools by clicking on the link in the description below that will take you directly to the Myschool website where you can get either the Myschool mobile app or get the Myschool software. This will give you a simulated JAMB CBT exam experience. So join me as we tackle question number 24. A supply of 400 volts is connected across capacitors of 3 microfarads and 6 microfarads in series. Calculate the charge. So we are asked to find the charge. So remember that when capacitors are arranged in series, this is what you should have. Okay, equals 1 over the first capacitor, then the next capacitor. Okay, so we have, which is equals to 1 over, so the first is 3 microfarads and the next is 6 microfarads. So what can we do? We can get the LCM, isn't it? So the LCM here is 18. 3 in 18, that is 6. 6 times 1, that is 6, okay? 6 in 18, that is 3. 3 times 1, that is 3. Remember the plus sign, okay? So this gives you 9 over 18, and this is 9 here 1, 9 here 2. So we have 1 over C equals 1 over 2. By the time we cross multiply, 2 times 1, okay, which is 2, equals C times 1, which is this, okay? So remember that the capacitance of a capacitor, okay, is just about the quantity of the stored electric current, okay, per unit change in the potential difference, okay? It's just measuring potential difference to the current. So this is what we are going to have. Q equals CV. From the formula, recall the formula, C equals, okay, Q over V. So when we cross multiply to make Q the subject of the formula, this is what we are going to have, okay? So Q equals, our C is 2. I remember the unit is microfarad, and micro means times 10 raised to the power minus 6, okay, times our voltage, which is 400. Okay, so if you want to do this, you can just have something like this, 10 raised to the power minus 6 times 4.0 times 10 raised to the power 2. Okay, anyhow you want to have it. So 2 times 4, that is 8 times 10 raised to the power minus 6 plus 2, that will be 8 times 10 raised to the power minus 6 plus 2, that gives you minus 4. So, and this is charge, so our unit is in columns, okay? So let's see which of the options goes with our answer. Okay, option A is correct. So do not forget to hit the like button, click on the subscribe button and tap on bell notification so you can get informed as we release the next videos. Here we have question number 25. A vibrator causes water ripples to travel across the surface of a tank, okay? The wave travels 50 centimeters in 2 seconds. And the distance between the successive crests is 5 centimeters. Calculate the frequency of the vibrator. So recall that V equals frequency, okay, times lambda, which is our wavelength. Okay, so from the question we are given that the wave travels 50 centimeters in 2 seconds. So that means we have to first get the value for V and recall that V equals distance over time, okay? Where the distance in this question is 50 over time, 2 seconds, and that should give you 25. So I haven't gotten V to be 25, okay? So that is 25 equals frequency. The question requires that we solve for frequency, okay? Times our lambda, which is the wavelength. Recall from the question that it travels and the distance between the successive crests is 5 centimeters. When you talk about crests, that's about the maximum displacement or the maximum height, okay, that the wave travels from the midpoint. Let me just put this easier for you, okay? So wave travels like this, crest and trough, okay, crest and trough. So this is crest up, this is trough beneath, okay? So the distance between the first crest and the next crest, okay, and there's a trough in between. So the distance between this crest and the next crest, that's what makes the wavelength. Okay, so the distance between this wavelength here is 5 centimeters from the question. I hope you get that. So that's what makes our lambda. So we are looking for f. Divide both sides by 5. So therefore, f frequency equals to 5 Hz. Okay, so let's go through our option. Option A is correct. Question 26. A thermocouple thermometer is connected to a millivolt meter which can read up to 10 millivolts. Okay, when one junction is in ice at 0 degrees Celsius and the other is steam at 100 degrees Celsius, the millivolt meter reads 4 millivolts. What is the maximum temperature which this arrangement can measure? Okay, this is very easy to solve. Okay, so we recall from the question that when it is deep into ice at 0 degrees Celsius, okay, this is 0 degrees Celsius and this is 100 degrees Celsius for steam. This is for ice. Okay, so when this arrangement happens, the millivolt meter reads 4 millivolts. Okay, so and that 4 millivolts means that is the temperature we have at 100. So 4 millivolts gives you 100 degrees Celsius. There was a temperature increase from 0 to 100. So at 100 degrees Celsius, it reads 4. Okay, so at what point will it read 10? If 10 is what we have, so we are looking for the temperature. Okay, because if you go back to the question, we said a thermocouple thermometer is connected to a millivolt which can read up to 10 millivolts. So we are talking about the millivolt meter now. It can read up to 10. So what temperature will it record on this thermocouple thermometer? Okay, so on the thermometer now, we cross multiply. So we have x times 4 equals 10 times 100. Okay, divide both sides by 4. Okay, 4 here 1, 4 here 25. So we have x equals 25 times 10, that is 250, divided by 1, that is still 250. Okay, so what is going to be read here will be 250 degrees Celsius. Okay, we're talking about the temperature here. Okay, so option what is correct? Option C is very correct. Number 27. An alternating current can induce voltage because it has what? Basically, what causes voltage to be induced is by the Faraday's law of induction, which involves a field, a kind of field. And basically in this question is the varying magnetic field. And the correct option here is option B. The varying magnetic field can produce this induced voltage. Option B is correct. Please remember that there are several solution providers on the Myschool website waiting for you to just ask your questions and gain clarity. Okay, so you can ask any of those questions right now. I have provided you with a link in the description below where you'll be taken to our website where the solution providers are waiting for you and answers will be supplied within moments. So join me as we tackle question number 28. The limiting frictional force between two surfaces depends on what? First statement, the coercive force of the material. We know that coercive force is just the intermolecular force that exists between a particular material, like a hydrogen bond in water, the weak van der Waals forces trying to resist separation. Okay, so this has nothing to do with friction. Okay, this coercive force also influence factor like surface tension in water, where you can see needles floating on water or certain insects walking on water. Okay, so this has nothing to do with the frictional force. So the nature of the surfaces in contact, that is very important, because the smoother the surface, the lesser the friction. The rougher the surface, the more the friction. That is why if you apply lubrication or lubricant to moving parts, you reduce friction and therefore you reduce wear and tear. Okay, so we have 3, the relative velocity between the surfaces. Of course not. So the only statement correct here is statement 2, the nature of the surfaces in contact. And that means option B is very correct. So perhaps you've gone through our videos and you've seen that there are 1 or 2 questions that you would like to give recommendations on how we can solve them or how they can be better explained. Please, I would like to know in the comment section below by indicating the question number and the solutions you would like to share. Okay, so we have question number 29 right before us. During the transformation of matter from the solid to the liquid state, the heat supply does not produce a temperature increase because the heat absorbed from the environment is used to break the bonds that are holding the molecules of the solid together. So if it's an ice, like in this case we are trying to use as our study, okay, so the ice will absorb heat from the environment, okay, and the heat energy absorbed from the environment is used to break the bonds that hold the molecules of the ice together. So definitely there will be no temperature change. So the correct option to the question above is how the heat is used to break the bonds holding the molecules of the solid together. So option D is correct. So we have question number 30. The statement heat lost by hot body equals that gained by cold one is assumed when determining specific heat capacity by the method of mixtures. Which of the following validates the assumption? So at first, lagging the calorimeter is very good because you can do that by using cotton wool, or you can use non-conductors, that is to diminish the amount of heat loss, okay? Though it doesn't account or allow for precision, okay? But lagging the calorimeter is one step in the whole process, okay? Ensuring that only SI units are used. 3, weighing the calorimeter and the lead and the stirrer. Of course, before the whole experiment commences, it is important that you weigh the calorimeter, you weigh the lead and the stirrer. So the correct options or statements we are going to pick to validate heat lost by the hot body equals heat gained by the other body, by the cold body. We are going to pick statements 1 and 3. So that makes option C very correct. So we have question 31 to tackle, okay? In the molecular explanation of conduction, heat is transferred by the what? This is just by the movement of electrons from one atom to the next neighboring atoms, okay? When it comes to radiation, that is through electromagnetic waves. So the correct option here is option A, the movement of free electrons from one atom to the next neighboring atoms, and such goes on due to the vibration of these particles. So option A, once again, is correct for emphasis sake. Down to question number 32. The conductivity of gases at low pressure can be termed as what? This is definitely a cold cathode emission and field emission, because this kind of emission are usually used in our fluorescent lamps, okay? And they are usually used together with mercury. So this typical setting is just what I've just explained. These are low pressured gases, or gases at low pressure, okay, used in our fluorescent lamps, and that entails cold cathode emission and field emission. So option C is very correct. So we have question number 33. Which of the following media allow the transmission of sound waves through them? So you should know that sound waves has to travel through a material medium, which can be solid, liquid, or gas, but never a vacuum. It's only light that can travel through a vacuum. And that is why you see that sound cannot travel through space, because there are no molecules to vibrate, okay? So sound can travel through all of this media, which includes air, liquid, and solid, okay? So Which of our option is correct? Option D is correct. So, my scholars, it is very necessary for you to prepare yourself using the Myschool tools that we have provided to help you in your preparations. So we have the Myschool mobile app or the Myschool software. So I have provided you with links in the description below where you'll be taken to our website to get the Myschool mobile app and the Myschool software so you can have a simulated JAMB CBT exam experience. So join me as we tackle question number 34. The Earth's gravitational field intensity at its surface is about, we're having G as 6.7 times 10 raised to the power minus 11. This is Newton meter square per kilogram square. Mass of the Earth is 6 times 10 raised to the power 24 kilograms. The radius of the Earth is given as 6.4 times 10 raised to the power 6 meters, okay? And acceleration due to gravity on the Earth is 9.8 meters per second square. So this is very easy. So remember the Newton's law of the gravitational force, or whatever you want to call it, which is given as F equals to G-M-M, okay, over the R square. So which is, the R square means the radius of the Earth and the radius of the other particle. This is the mass of the Earth. I can make it bigger. Okay, so this is mass of the Earth, all right, and this is the mass of the other particle, and this has its own definite value, okay, mass of the Earth, which we are given here as 6 times 10 raised to the power 24 kilogram. Okay, so now recall that we have E equals F over M, isn't it? So which is for the other particle. So recall that F is what? G, M, let me make this M big for the mass of the Earth and the other particle, okay? Multiplied by this, then this other particle, okay? So R, M strikes out M, so we are left with G, the mass of the Earth, over R square, okay? So we have the value of G. Let's transfer what we have here. So we are given the value of G as 6.7 times 10 raised to the power minus 11. Although this is an approximate value, okay? But it's still going to get us near where we are heading for. So we have the mass M of the Earth, which we are given as 6.0 times 10 raised to the power 24, okay, over our R, the radius of those particles, which is 6 radius of the Earth, and the other particle, which is given as 6.4 times 10 raised to the power 6. So remember it is squared, okay, so this is what you can do. 6.7 times 6.0, that should give you 40.2, okay? So times 10 raised to the power minus 11 times 10 raised to the power 24. Just bring them together, we have 10. So that is 24 minus 11, that gives you 13 over 6.4 raised to the power 2, okay? That should give you 40.96. So this is 10 raised to the power 6 raised to the power times 2. That is 2 times 6, that is 12. Or 10 raised to the power 6 times 10 raised to the power 6. That is still going to give you 10 raised to the power 12, okay? So times 10 raised to the power 12. It's very easy. 6 times 2, that's 12. Okay, so if we divide this, we should have 0.981 blah blah blah. Then times, this is 10 raised to the power 13 divides 10 raised to the power 12. Just say 13 minus 12, divide change to minus, okay? 13 minus 12, that is just 1. And 10 raised to the power 1 is still 10. So if 0.981 multiplies 10, what you are going to have is 9.8. So join me as we go through our options. So you see that option D, it's very correct. So don't forget to like our videos, click on the subscribe button and tap on bell notifications so you can get informed as we release the next videos just for you. So question number 35, the following are part of the eye. So let's look at the retina. The retina is responsible for the absorption of light, okay, into the eye, and that is about image formation. It collects this light and sends them as biochemical messages to the brain, okay. Then we have the pupil and the iris, okay. The pupil is the black spot inside of your eye that is sitting at the middle of the iris, okay. The iris dims itself so that it can take in more light when the light in the environment is very low, okay. And when the light is bright and much, the pupil will contract, it will become smaller. So the retina has a structure similar to the film in our camera, or we can say the film in our camera has structure similar to retina, okay. So the pupil is similar to the aperture in the camera, then the iris is similar to the diaphragm in the camera. So the correct arrangement is option D, the film, the aperture and the diaphragm, option D. Down to question number 36, okay, I'm super excited. According to kinetic molecular model in gases, okay, let's look at which of the statements are correct or is correct. The particles are closely packed together, they occupy minimum space and are usually arranged in a regular pattern. No, that is not for gases, okay, so you can refer to this for solids. Okay, so B, the particles occur in clusters with molecules slightly further apart. No, not for gases. Option C, the molecules are very far apart or they move fast, okay, and occupy all the space made available, of course. So if you release gas into a container, they are going to move. The molecules will move as far apart as possible, as fast as possible. They collide with each other in random motion inside of the container and they try to fill as much space as possible. For you to reduce the space they are going to fill up, that means you have to increase pressure, because increase in pressure means decrease in volume. Okay, so we have option D. The particles vibrate about fixed positions and are held together by the strong intermolecular bonds between them. This is a description for solids. So what's fitting for gases in the kinetic molecular model is option C. So join me as we tackle question number 37. The force of 6 Newton acts horizontally on a stationary mass of 2 kilograms for 4 seconds. The kinetic energy gained by the mass is what? So join me as we go and provide solution to this problem. So we recall that the formula for force is mass times acceleration, of course. So where acceleration is change in velocity over time taken, isn't it? So we would have F equals to mv minus u over t when we cross multiply. So we would have Ft equals, all right, m into bracket v minus, where the initial is, we are told that the body is at rest, so that is initial velocity is 0. So v minus 0 still gives you v, okay? So let's just have v. All right, so join me. So we have dividing both sides by m. Okay, so velocity will be equals to, final velocity equals to Ft over m, that is force times time taken over the mass. So recall that the formula for kinetic energy, Ke, equals half mv squared. Okay, so let's plot in the values. We have half times m, which is giving us 2 kg. All right, okay, times our v, which is Ft plus m. So what is the value of F? We are given the force as 6 times our time, 4 seconds. Okay, over our mass, which is still 2 kilograms. So remember we said v squared, so this will be raised to power 2. All right, so let's transfer our values. Just join me. So our kinetic energy will be equals to 2 strikes out 2. 6 times 4, that is 24. 24 divided by 2, that is 12. So we have 12 raised to power 2, okay? And that equals 12 times 12. And that gives you 144. Okay, so your answer is 144 joules. That's energy. Okay, so that's your answer. So you can ask your questions right now. Solution providers are waiting for you on the Myschool website, and I have provided you just with the link that will take you right there. So we have question number 38. The momentum of a car moving at a constant speed in a circular track is what? Okay, so recall that momentum is just about the tendency of an object to move in the same direction with the same speed, okay? So, and that deals with the acceleration pointing towards the center, okay? And that also shows that the velocity is constantly changing, okay? And that is by centripetal force. So, of these options that we have here, option C is correct because it can be 0 depending on its position in the track. So remember, all of these questions are being sourced from the Myschool website. So I have provided you with the link so that you can go to our classroom and get these questions so that you can begin your personal study right now, or probably follow up with the video clip tutorial as you and I connect together. So we have question number 39. A metal rod has a length of 100 centimeters at 200 degrees Celsius. At what temperature will its length be 99.4 centimeters if the linear expansivity of the material of the rod is 2 times 10 raised to power minus 5? Okay, that is Celsius for you. So linear expansivity equals change in length, that is L2 minus L1 over the original length times change in temperature. Okay, so here we are asked to find, said, if the linear expansivity of the material of the rod is 2 times 10 raised to power minus 5. So we are asked at what temperature. So we are asked to look for the second or the final temperature. So if you make the final temperature the subject of the formula, we're going to have something like this. Okay, just follow me step by step. It's very, very easy to solve. So divide both sides by this. Okay, linear expansivity and the initial length. This strikes out at this side. So I'm going to make this the subject of the formula. That means theta 1 will cross over to become positive. So we have the final temperature equals L2 minus L1 over, okay, alpha times L1 plus theta 1. Okay, so now let's plot in our values, which is, so we said a metal rod has a length of 100 centimeters at 200 degrees Celsius. At what temperature will it be 99.4? So the initial length is 100, the final length is 99.4. So that will be the final, which is 99.4 minus 100, okay, over the linear expansivity giving us 2 times 10 raised to power minus 5, okay, times the initial length, which is 100. So that will be equals to 99.4 minus 100, that is minus 0.6 over 2 times 10 raised to power 5 times 100, that should give you 2 times 10 raised to power minus 3. Okay, I hope you know how I got 2 times 10 raised to power minus 3. Okay, so don't forget our theta 1 beside it. So theta 1 is giving us 200 degrees Celsius. So if we bring this, so when we divide this, we are going to have, just look at it, when you divide minus 0.6 divides 2 times 10 raised to power minus 3, you're going to have minus 300 plus 200 So that should give you minus 100 degrees Celsius. So theta 2 is minus 100 degrees Celsius. Here we are at question number 40. The lead acid accumulator consists of, at first it has the negative electrode made of the metallic lead, The positive electrode is made of lead oxide, and they are just dipped in the electrolyte of dilute sulfuric or H2SO4 as the electrolyte. So if you go through all of these options, you will confirm with me that option D is correct. Tetraoxosulfate 6 acid as the electrolyte. So dear my scholars, that is the end of this segment, but you know that there is definitely more to come. So for you to keep in the flow, make sure you hit the like button, click on the subscribe button, and tap on bell notifications so you can get informed as the next videos are released just for you.